Okay, so we are going over the law of sines. So we did a bunch of these of triangles. I think I'll pull this up first. Hold on. We did a bunch of these triangles where we had to find. What am I doing? Where we had to find sides and angles of non-right triangles. And the one of the methods that you all used was I'm going to draw an auxiliary line, and it was very kind of like specific on where you should draw it. The first one we did, we just drew the very first one and we were able to do it. What you're looking for whenever you're drawing an auxiliary line is when I draw an auxiliary line, I have an angle and a side. If I have an angle and I have a side, I can guarantee you I can find the rest of my answers. Okay. Like as opposed to, if you remember, we drew this auxiliary line in first. Auxiliary again just means extra line. It doesn't appear in our original diagram that they gave us. So when we drew this one in, it wasn't helpful because we didn't have an angle because we kind of like cut this angle, but we didn't necessarily bisect it, right? So we cut this angle, so we didn't have any angle, but we did have a side. So we drew another auxiliary line this way, and then we did have an angle and a sine. Yeah, that's fine. And a side. Okay. Whenever we have in a right triangle, an angle, and a side, I need two pieces of information, right, in order to find the rest of this stuff. Or I could have two sides of a right triangle, then I can use the Pythagorean theorem. The same thing follows. Okay. So in general, we were going to talk about this one, and I'll talk about this one really quick. That once we figured this out, right? So we draw our auxiliary line in and say here. And this one's asking for it in general because they want us to prove something. They wanted us to look at all of the generalizations that we can make from here. So here's us building this really quickly. So if I draw an auxiliary line here, and this is an altitude, right? I could then use the information here to find all of the information that I needed. So this is the funny part for students because you sometimes feel uncomfortable because you don't have any numbers. So if I was to write some information down, and let's just say this is H for altitude, right? Could I write some equations based on the information that I have here? And everyone should say, yes, yes, you can. Okay, so give me an equation. Now, the equation is going to have many variables because we have no numbers. But can someone write me an equation that would be legit in order to find either a side or an angle of our original triangle? Can you find me an equation that I could write? Now, some of you are thinking, well, I can't use Pythagorean theorem because I don't have enough sides of that right triangle, right? So you should definitely be looking at this. So what do you guys see? What's an equation that we could write? Okay, so someone says sine B equals H over A. And I remember too that some of you will write equations wrong, and I want to make sure that this person writes it pretty well. So I'm going to snip it so that you guys can all see that I'm not talking to myself. Snip this. Let me grab this. Oh no, your faces are in our way. Hold on a second. Dang it. Jeez, that took forever. All right, so yes, one of our equations could be sine of B equals H over A. Perfect. What's another equation? What's another equation we can write besides sine of B equals to H over A? Yeah, it doesn't matter. From wherever. Yeah, you can use whatever. I don't care. Okay, someone else says sine of A. Where did it go? Our faces are in the way of me finding my thing. Sine of A equals H over B, right? Perfect. Right? So literally I do not need right triangles in order to build stuff. No, that one's not correct. Someone wrote cosine of A equals H over B. Can someone help this their classmate out? Why is cosine of A equals to H over B wrong? Why is cosine of A equals to H over B wrong? Yeah. Cosine of A is adjacent over hypotenuse because it's C-A-H. So that's not right. So make sure you fix that before our test on Wednesday. Cosine. Yeah, cosine is adjacent over hypotenuse. Someone else said cosine of B is A over H. No, cosine of B is not A over H. So you guys got to fix this before your quiz on Wednesday. So if there's a couple of you, just remember SOHCAHTOA. Go through those problems and make sure you're super comfortable with it, because otherwise this is what's going to knock you out of the on your test, right? Yeah, cosine is again adjacent side over hypotenuse side. Cosine of C is H over A. It depends on if you're saying the C right here. How many angles are coming out of angle C, guys? Very good. Someone said, remember the eyeball tip, right? Your eyeball is looking at the opposite. Yeah, there's 3 angles coming out of C. So whoever said cosine of C, I think you might have been using a, what is it called? You may have drawn another altitude, right? Okay. So if you're saying this small angle in here, then I wouldn't say cosine of C. I would definitely rename it. So then what do you all notice about these two? Anybody notice does anybody see anything that these two have in common? I'm just going to use these two because this is going to help me build my next thing. Oops. No, I'm frozen. Does anybody see anything common between that one and this one? Does anybody see anything common? Sorry, my window was frozen. Yeah, which variables? Be specific. Which variables do you see as the same? Which variables are the same? Yeah, H is the same. So in these two variables, does everybody see how H is the same? So when I have variables like this, just stay with me for just a second. I'm going to solve each of these for H. I'm going to solve for H here. How would I solve for H here? What would I do to both sides? What would I do to both sides? Yeah, good. Multiply by A. Very good. So I'm going to multiply this by A, multiply this by A. And then the A's would divide out. So I get A sine B. Now, for those of you who write capital letters for everything, make sure you're using lowercase letter a here. I should be able to say little a, and you should all be saying, oh, that's a side. I should say big B here, and you should be like, oh, that is a, what is it called? An angle. Okay. So this angle here, very good. Hold on. My thing is catching up. Okay. And then same thing goes here. I'm going to solve by multiplying by B on this side and B on this side. So I get H is equal to B sine A. Mathematically, what would you all do next? Man, can you catch up to me? what would you do next? This one says A sine, oh, there it goes. A sine B. And this one says B sine A. Mathematically, what would you do next? Hold on, let me let this catch up to us. Now that you have these two equations, what would be the next step? Anybody see the next step? You have H equals this and H equals this, right? Mathematically, yeah, you would just set them equal to each other. Very good. You would set them equal to each other. So you get A sine B equals to B sine A. A sine B equals to B sine A. Okay. So as soon as this shows up here, what it's now saying is I have a relationship between this guy's side with this guy's angle. I have a relationship between here. So this is actually called your law of sines, but I'm going to clean this up a little bit so it looks a little bit more friendly. And so the way you would normally see it is like this. You would normally see the law of sines look like this. Sine of B over B equals to sine of A over A. And if you continue this thought out, you would also have sine of C over C. Okay. So I would divide by A over B because this is your law of sines. This could be used over and over again. So you know how with our right triangle trig, we need right triangles in order to use this definition of SOHCAHTOA. For this law of sines, this works for anybody. For this law of sines, it literally works for anybody, any triangle. Does that make sense? So this is our law of sines. So I'm going to write law of sines. Okay, that's actually how you spell sine. Sine is not spelled S-I-N. That's a shortcut. Okay, this is 15. So here's your law of sines. This is it. So make sure that you are super comfortable with this law of sines. So what does this mean, Miss Johnson? Well, this means instead of you guys drawing in auxiliary lines, as long as you have this set here, you'll notice that you can pluck out any two and use it for an equation. Like how, Miss Johnson? Okay, so let's see. Let's look at this original triangle that we have here. Can you guys all see it? So I'm gonna use the law of sines right here, and then we're gonna move on. So I'm gonna redraw this triangle here. It's 8, 13.8, and 35. So it's not gonna look the same, but you guys all get the picture. And then this is A, B, and C, and this is letter C. Okay. So I draw this picture again, and I say, hey, can I use the law of sines on this? Can everybody really quickly fill out the law of sines? Just plug this in, pencil and paper, whatever you want to do, just write this out. I need you to be comfortable with this formula. Not very difficult to memorize, as you can see. Sine of B over B equals sine of A over A, sine of C over C. This is why I don't like it like this. I like it like this. So go ahead and fill that out. Some of you already done. Thank you for sharing in the chat. I appreciate that. So again, all you're doing is you're doing this problem using this formula. This is actually a law. A law means that it works, like the law of gravity, right? It's not like some of the things work, it's like all of it works. All right. Can you start putting your answer in the chat? Can you start putting your answer in the chat? So technically there's no hypotenuse, right? Why isn't there a hypotenuse, guys? Technically there isn't a hypotenuse. Why not? Yeah, there's no right angle. No right angle, no yeah, exactly. Good job. No right angle, no hypotenuse. Hypotenuse is specifically reserved for the longest side in a right triangle. So I think I know what you're saying, but just fill it in according to these A's, this B. And remember little a, where can I find little a? He's always going to be opposite of who? Little a will always be opposite of, yeah, big A, like this, right? So again, it's that eyeball trick. A likes to look at little a, C likes to look at little c, B likes to look at little b, right? Remember the eyeball thing? All right, let's move on. So here I go. I'm just going to write my equation out. It's going to look like this. I'm going to start with sine of A. I don't know what A is, so I just write sine of A over 13.8. If you got that, give yourself like a pat on the back. Awesome work. And then I'm going to move on to sine of B, except for B, I know what it is. So it's 35 degrees divided by 8. This is going to be my helper. This equation, this proportion in the middle, this fraction, sine of 35 over 8 is going to be my helper. Why would I call sine of 35 over 8? Why would I call him my helper? Why would I call him my helper? Why would I call sine of 35 over 8 my helper? Yes, because I know you and I know you. Here, I don't know you. But that's okay, because like if I look at just this proportion right here, proportion meaning fraction equals fraction, good. This guy over here, sine C over C, useless to me right now. He's useless. Why is he useless? Because I don't know and I don't know. So I'm going to ignore him and I'm going to solve this equation, right? So I'm going to multiply by 13.8. So I'm only looking at this side right here, right? So I go multiply by 13 over 8. That's sine of A equals to 13.8 sine 35 over 8. You guys are uncomfortable because you want me to plug in sine 35. As a mathematician, you wouldn't do that. As an engineer as well. Okay. So I just multiplied both sides by 13.8. You guys all see that? Anybody remember this? How do I get A out of sine? How do I get A out of sine? How do I undo it? How do I undo it? No, not multiply. What is it called? Yes, inverse sine. Everyone say inverse sine. Inverse sine. So I'm going to sine inverse everybody like this. That's why I moved him over. Oops. Undo that. Why did you do that? Sorry. Okay. So I'm going to sine inverse both sides. It looks like this. So I write sine to the -1, but we call it inverse. Right? So again, for those of you who said multiply or divide or anything like that, no, get that out of your head. I'm so glad you made that mistake today. I'm so glad you made that mistake today. Ms. Johnson, am I going to have to show this work on the test? Yes. Please do. Okay, these two should cancel just like adding and subtracting the same exact number cancel. And so I have this answer. And so what I'm going to do is I'm going to steal Desmos. I'm going to find my Desmos. I'm going to find my Desmos and I'm going to plug it in. I'm going to plug this whole thing in. Miss Johnson, before you even start plugging in, you should check to see if what? Miss Johnson, before you even start plugging in, you should check to see what? Divided by, that works, 8. What should I be checking? Very good. Are you on degree or radians? Yay. Okay, so that's better. 81. What did I just find? Where am I going to put that 81 in my diagram? Where am I going to put that? What did I just find? Yeah, I found A. Very good. So I'm going to put 81.6658. Okay. Next. Miss Johnson, you said this guy was useless. But how are you going to find it? Because you don't know C and you don't know C. Anybody see what we should do? Anybody see what we need to do now? That's why I always bring it back to the picture. Looking at this picture, what am I going to do next? Looking at this picture, what am I going to do next? Yeah, how would I find C? Big C or little c? How would I find big C? Very good. Thank you. How would I find big C? Man, I got to give people points, man. You guys are belting out a lot of good work here. Yes, subtracting from what, hun? Very good. Two of you got it. Subtracting from what? Where are we going to be? Very good. We're going to be subtracting from 180, yes? All right, so I'm going to go from 180. So I'm going to go 180 minus, oops, 180 minus, and then 35 and 81.658. So 35 and 81.658. So it's going to be about 63.32. So I'm going to squeeze that guy in there. 63.342. If you forgot that, you need to make like a little bubble right here. Like, don't forget the triangle sum of the angles adds up to 180, right? Very good. Very, very good. Very good. So for some of you who forgot that, yeah, don't forget those things. They're important. And then I'm going to plug them into here and then find C. That's all I have left to do. So I'm going to do that really quickly. So I'm going to plug them into here. If you know Miss Johnson, which equation would she use with C? I already know that I'm going to write, let's see, I know I'm going to write sine of 63.342 divided by C. But which equation should she use? I mean, which proportion, which ratio should she use? Sine of B over B or sine of A over A? If you know Miss Johnson, which one is she going to use? Sine of B over B or sine of A over A? Yeah, why B? That's right. Everyone, very good. Thank you. Why would I use B? Why wouldn't I use A? Yes, very good. Someone said B over B because I know both of them. Technically, I know A. But what does Miss Johnson always do? If I have a choice to use information that they gave me or that I found, which one is Miss Johnson going to use? Very good. The one that they gave me, right? All right. So solving this thing, a lot of you do different things. Some of you cross multiply. Some of you multiply by the thing. I'm going to do something different because I want you guys to see that you like different things that you can do. This is a true statement. If this is true, did you know that this is true? Did you know that this is true? Oh, you're slow today, buddy. Yikes, come on. There it is. So if this is true, did you all know that this is true? Have you seen this before? So you can play with it. You can say 10 divided by 2 is equal to 6 divided by 3, right? Just this is you just checking in your head, like, does it make sense? So 10 divided by 2 equals to 6 divided by 3. That's not true. That's not true. Sorry. Hold on. 15, rather. So 10 divided by 2 is the same as 15 divided by 3, right? And if I handstand them, I call it a handstand, right? If I handstand them, 2/10 is the same as 3/15, right? So this is 5, this is 5. And if I handstand them, they'd be 1/5 and 1/5. It's true, right? So the first thing that I do as I do this, I like to show you guys different ways to do the same thing because then it gives you alternative paths to the same thing. Then I'm just going to multiply by this guy. So I get 8 sine 63.342 divided by sine of 35. Ooh, it looks like sim 35. Sorry. Okay. Equals to C. And then I'm just going to straight plug that into my calculator because that's what I can do, right? So I'm going to take this whole thing that I wrote here that you can't see right now. So 8 sine 63.342 divided by sine of 35. That's my answer, 12.465. So C is about 12.465. It still hasn't caught up. So there's my little c. And then make sure that your answer actually makes sense, right? If my answer makes sense. So is it possible for me to have a triangle that has sides of 8, 13.8, and 12.465? And you guys would be like, yeah, that seems about right. If this became 12,465, do you see how this is wrong? Someone says, could you re-explain how you got the information in the parentheses? This guy? Right here? Yeah. So I took this side and I'm solving for A, right? So I need to get rid of 13.8. So how would I undo dividing by 13.8? Very good. Very good, right? That makes sense. Does that make sense? Perfect. Okay. So there's the answers. And if you compared these answers, let me move this over here to all the way back here, we got, let's see, 11.304. And you guys are like, but Miss Johnson, this one was 12.465. It's a little bit off because of how we rounded everything, right? So this answer here was a rounding from an answer over here. Let's see, X, where's my X? X, 11.304 is coming from cosine. Oh, no, but I had to add these two together. Just kidding. If I add 11.304 plus 1.163, it's about 12.4, right? And then if I look at this angle in here, 81.64, I got 81.66. Still okay. I got here 63.36. I got over here 63.34. Miss Johnson, is that close enough? Yeah, that's really close. So what do you prefer? Okay. Did you prefer all of this work that we did up here? I need to scoot over here. All of this work that we did up here to solve this triangle? Or did you like the law of sines better? Great. Do this work. How do we show this work in Desmos because the triangle changed? Yeah, I vote for the law of sines too. I'm in agreement with you. Because there's a lot less to do, right? But it's not like if you forgot the law of sines, you're going to be like, right? Yeah, the law of sines is definitely, as soon as I see this, then it'll work. The only problem is, and then this goes to our takeaways, which I hid back here. So here's our law of sines, right? It says if I know two sides and an angle, that should be TWO, not TO, or two angles and a side for an oblique triangle, then I can find the missing sides using the law of sines. Okay. So there's another law called the law of cosines, which I also want to show you really quick. Actually, I will stop you here.